Hello. Today we're going to be going over the Galapagos Islands. This is by me, Tanner Myers. The Galapagos Islands were very interesting to me just because there's such a multitude of history and such a wide variety of things to cover. So the things that I'm going to be covering is the formation of the islands, the basic marine biology, the discovery of the islands. I'm also going to be going over Charles Darwin just a little bit just because he made his discoveries at the island, so it doesn't directly pertain to uh, this ocean's class, but it does directly pertain to the Galapagos Islands, so I did not want to leave that out. We're also going to be covering the ecosystem, the marine organisms, the El Nino effect on the islands, the warming water effect of the islands, the health of the ecosystem, the seawater around the islands, and the coral reef of the Galapagos. So let's go ahead and get into the direct overview. So, as you can see, there's a bunch of chains of islands to the left over there. And these islands are all a province of Ecuador. So they are located on the Nazca Plate. That says chain of 13, but I think I made a slight mistake. There's actually 18 major islands, and they are just off the eastern Pacific coast. Those 18 islands are Wolf, Santiago, Santa Fe, Santa Cruz, San Cristobal, Rabida, Pinzon, Pinta, North Samar Island, Marchena, Isabella, which is the biggest of the islands. As you can see, it's that giant one that looks like a backwards L over there. Genovesa, Florina, Fernandina, Espanola, Darwin, Bartolome, and Baltra. As you can see, I had to have butchered some of those. They are mainly Spanish because it is obviously, as you can see, a province of Ecuador, so that is why they are so Hispanic in nature. So let's go ahead and move on to the formation of the islands. The formation of the islands is basically because of hotspots. So heading eastward over the Galapagos hotspot has formed these chains of islands. The islands were formed through the layering and lifting of repeated volcanic action. The eastern islands are millions of years older than the western, just because of the way that they were shifting. So they were moving eastward. So they are quite young. So the westernmost islands are only maybe hundreds of thousands years old and still being formed, and the eastern islands are about no more than 5 million years old. So that's a giant gap over time just from them moving over these hotspots. So the formation of these islands continued is, they are mainly cone-shaped islands. So they are mountainous islands that have formed through continuous eruption, building layer upon layer over a long period of time. Due to this formation, the islands are characterized as many steep slopes with heights ranging from a few meters above sea level to more than 5,000 feet above sea level. But there is one exception, and it is Isabella. Isabella is giant, and it was about six volcanoes and eruptions, and they've all kind of built layer upon layer and kind of conformed over time. So that makes that island way bigger than the others. So some basic marine geology. Generally, the individual islands form from a single shield volcano's eruptions of basaltic lava flows expanding its shores. However, like I just explained, the largest island, Isabella, is made up of 6 volcanoes which have flowed into each other, filling those giant gaps in between. So they're not giant gaps. I guess they're combined now, but some more basic marine geology is there are also reefs, underwater cliffs, wetlands, and lagoons. So now that we kind of have like a nice overview of everything about the island, let's go ahead and get into the discovery. So the Galapagos Islands were discovered in 1535 by the Bishop of Panama, Thomas de Berlanga. Like I said, I probably am butchering these names and stuff, but I am not very good at Spanish. But his ship has drifted off course while en route to Peru. So Berlanga named the islands Las Encantadas, which translates to the Enchanted. And in his writings, he marveled at the thousands of large Galapagos, the tortoises, which the islands are very, very famous for because they live to be very old and they are massive tortoises. So I just want to briefly cover Charles Darwin because he is very important to the island's history. He wrote a book on the origin of species, where he basically made the discovery of natural selection. His argument was that if individuals vary with respect to a particular trait, and if these variants have different likelihood of surviving to the next generation, then in the future there will be more of those with the variant more likely to survive. So basically, he's talking about evolution and survival of the fittest. He made the discoveries on these islands about that if there are traits that are not ideal to the survival of a species, then they will mutate, and eventually those mutations will move on into the next generation and ultimately be overall. Like I said, this is not doesn't really pertain to the oceans class, but it is very important to the history of the Galapagos Islands, so I just wanted to briefly put that in there. So let's get back on track and get into the ecosystem of the islands. So on the Galapagos Islands, there are three major ecosystems: terrestrial, coastal, and marine. In the years of El Nino, the ecosystems show their characteristic behaviors. In the terrestrial zone, predominant heavy rains, which has a positive effect on the animals and the plants because they're getting that extra water. In contrast, the marine and coastal zone, the high water seaweed is destroyed, which causes marine iguanas to starve, and they are unable to reproduce. Same thing. Marine. So let's go ahead and get into the marine organisms. So it's all overseen by the Galapagos Marine Reserve, just to make sure that everything stays the way that it needs to be. But some of the main marine organisms are whales, dolphins, albatrosses, sharks, sea lions, penguins, fur seals, rays, marine iguanas, sea turtles, and many, many tropical fishes. Underwater volcanoes or mountains, known as seamounts, rise to near the water's surface and provide feeding grounds for some fish such as tuna and sharks, as well as birds, sea lions, and turtles. There are also reefs, underwater cliffs, wetlands, and lagoons. So let's go ahead and get into the El Nino effect. The 1982-83 El Nino Southern Oscillation warming event increased water temperatures in the Galapagos 3 to 4 degrees Celsius above the usual maximum sea temperatures, which 3 to 4 degrees does not sound like a lot, but that is a major deal and can create some health problems to the ecosystem. So let's go ahead and get into the health and productivity of the ecosystem. So this warming of the water, the warming physically stressed Galapagos corals, causing them to expel the algae leaving in their tissues and become completely white or bleached. This and other similar coral bleaching events, coupled with the naturally occurring high levels of carbon dioxide, made it difficult for coral reefs to rebuild their calcium carbonate skeletons. None of the Galapagos' southern reefs show signs of revival, and the only reef that is recovering is off of the far north island, which is the island of Darwin. So that is some pretty major effect to the ecosystem, that it's absolutely destroyed most of the coral. Yes, like I said, the only one that is recovering is the far northern island, Darwin. So let's go ahead and get into the seawater. The Galapagos Islands are a unique habitat that allows scientists to study many ecological conditions, including exposure to naturally high levels of oceanic carbon dioxide. Greater levels of carbon dioxide result in lower pH levels in seawater, making it more acidic. Waters with high carbon dioxide can have negative effects on some organisms, like corals, that build their skeletons underwater. These naturally high levels of carbon dioxide surrounding the Galapagos are a present-day example of conditions expected throughout the rest of the tropics by the 2050s. So they are using the seawater kind of as an experiment to see what's going to happen in the future. And so yeah, that is their kind of experiment on the seawater. So the Galapagos Reef. In the Galapagos Marine Reserve, between 95 and 99% of coral reefs were lost in that 1983 and 85 El Nino effect. The extreme weather conditions just destroyed so much of the reefs. So what we're going to get into now is the restoring of the coral reefs. So some of the coral reef communities have recovered, but since the habitat conditions that they create are of extreme importance, it is key to know if Galapagos' coral reefs can undergo a process of restoration called coral farming. So what is coral farming? So coral farming is a process whereby fragments of corals are collected from local reefs, raised in farms until mature, and then installed at restoration sites. So basically, they want to try and they want to take these fragments and they want to restore them in a place that is more safe, and then they will put them back into the sites. So that would be huge, considering that 99% of the coral reefs have been destroyed, and it would be amazing to see those come back to fruition. So in conclusion, we went over a lot of the Galapagos Islands in a very short amount of time, but it was very interesting to see and learn about the formation of the islands, the basic marine biology, to get kind of the history of the discovery and of Charles Darwin, to get an overview of the ecosystem, to know the marine organisms, to really figure out how the El Nino effect affected everything, the health of the ecosystem, the seawater, and the coral reef, and ultimately the restoration of the coral reef. So it was very interesting to learn about all of this. So it was a pleasure to kind of look and learn about something that I personally have no idea about. I'm not a big science guy. I'm not into this at all, but this was very interesting to go over and really look at. Here is a few, and there are the other ones. So I just wanted to thank you for your time. I had a great time in your class. And yep, that is it. The Galapagos Islands.